Hey all, welcome back to this video where we will be looking at data processing, which happens to be part of machine learning practice paper part 1. And mainly we will look at different methods on how you can apply things, and I will share you some tips that will help you to do better in general. So first thing is loading data. So as you can see here, I have a dataset link. If I go and click, you can see that we have our housing data and by the names of all the features or columns. And you can even see your metadata, which will help you later on to process your data very easily. Now, there is one issue sometimes which I see people face is that there is no data in their environment. So for that, just download this particular CSV file. And you can see that here we have our CSV file. Now go to your working environment. Let's say we are going to a collab file. And here, as you can see, it is not yet connected. So first of all, connect your session. And once it is connected with this tag, just go here and click on this upload, select your file. So we have downloaded this file. So I will be selecting this file. And now it will take some time to load, and once it's loaded, it will be visible here. Okay, so you can see that it's visible here. But for the most cases, in normal programming exams or in general, you will have your data in your environment like this. So you can directly load your data using the name itself and get started with it. So let's do that next. So assuming that you have already read your metadata, we first need to import our tools of trade, that is Pandas. Now, for that, you can do import Pandas as pd and import NumPy as. So you do this, it will take a little bit of time. And now you can see that it's already loaded. So once you have your library ready or tools of trade ready, now we need to load our data. So loading data in Pandas is very simple. First, you need to create a data frame or df abbreviation variable, and then you have to do pd.read underscore csv and name of your file, whatever is that. So for us, it is preprocessing.csv. So just I'm going to take this and pass it in a string code which represents the file path, and make sure that you have this CSV at the last. Okay. Now let's check few values from this if we have loaded it successfully or not. So for that, I will be doing tf.headman. And you can see that we have successfully loaded our data. Now let's look at metadata once again. So CRIM is per capita crime rate. ZN is amount of residential reserved in vicinity. Indus, proportion of industrial land reserved nearby. In square kilometers it is. Riverside is in boundary faces riverside. Pool index is pollution index. RM is number of rooms in house. Age is age of the property in years. DIS is weighted distance to the major economic centers. Highway count is number of highways within 5 km of distance. Taxes, full value property tax rate per 1 lakh. PT ratio is student teacher ratio in vicinity. IIM is immigration index in vicinity. BPL percentage of below poverty line population in vicinity. And price is price of room in lakhs. That this is a target column. Now you might think, why I am reading all these things so that you know? Because that is very important in your workings. Because if you know what all features you have and how you can interpret them, it's very easy, right? And just for a sanity check, we will check the shape of our data. So df.shape. So it says 4000 rows and 14 columns. That means that this 4000 is number of observations and 14 is number of features, out of which one value, which is our price, is our target column. As you can see, it's written here. So these are type of inferences that you can understand from your metadata. Now, once we have this, let's start solving few of the questions that are commonly asked. So let's start with our first question. And in this, you need to say which is the dataset that you are using in this particular examination. And here it says npp1 processing.csv, and I'm getting this from the name, as you can see here, right? So just print them, that's all. Second is how many samples are there in dataset. So for that, you can simply do a df.shape and just print it. You can see that it's 4000, 40, right? So it is a tuple and it simply means 4000 observations or samples and 40 features, out of which the 14th feature, that is price, will be our target column. You can directly do shape of 0 because that's the observations. So it says 4000. So that's your answer for this question. Next, what is the average house price in lakh, because that's the target. So for that, we can do df of capital price dot mean. And the reason we can apply mean is because when we just do a simple print, it returns a series type of object. And based on that series, you can simply do a aggregation operation, which is mean, right? So this is done. So it says 24.35 lakh on an average is the house price. Now, next question is, how many houses have 5 or more rooms in common? So if you have not read the metadata, you might think that it will be room, but here you can see that it's RM. So that's why I said that green metadata. Okay. First, we will filter and check. Okay. So for filtering, you can do df of RM greater than equal to. If I do this, you can see that it returns a series with Boolean values true or false, right? But to assign it to new data frame, we will use df of this, right? And you can see that now we have our data frame where all the room are either 5 or more than 5. And it says how many houses we have. So either you can directly do it from here, which is 3953, or you can directly use save method using the function chaining. And it says 3953, right? Now let's move on to our next query, which is what is the average price of top 10 most expensive houses in land? There are multiple ways again to do this, but here's the most simplest one. First, filter out top 10 and then get the average. Obviously, you can do it in 2 steps. On 1 step, I am going for 2 steps. Okay. So I will write top 10 is equal to df dot sort values, because this will sort the values based on the condition you will be passing for that particular column. So what column we want? We want price, because it says prices of top 10, right? So for this, we have this parameter by which column you want, and then what is the condition? Is it ascending or descending? For that, we have a parameter called ascending is equal to false. That means it will sort in descending order. And if I do it directly, you can see that it's 4014 columns, right? So we don't want that. What we want only 10, top 10. So that means we can do dot head and then 10. Obviously, this will only take top 10 values. And since we have already sorted everything, you can see that the price which are highest are at the very top because it's in descending order. So now if I do, you can see only 10 is there. And now you can again access the price column with this. So price and then dot mean. And you get 52.36 lakhs for the top 10 samples or observations, right? So this is the main crux. Don't directly do it. You might get caught up. Sixth question. What is the total number of missing or unknown values in number of room features? Hint. Carefully look at the values the feature takes and find the impossible value. And here I have seen people doing error in my normal work. And what they do, they just do this. df dot is na dot sum. And you can see that it says 0 and you might get right, it's 0, so let's write that 0. But that's not the case. It is a false indication and you need to work on this. And for this, it's better that you try to print unique values. And it says for room features, right? So again, if you do this df.rl, as it says 0, so we need to inspect it, right? So for inspect, we will do unique, right? And if we do unique, you can see that it's a -1 there. So -1 means it can't be, right? Because how can room be -1? So that is the thing. And now you need to filter that based on that. And then you need to get the shape of the value so that you don't have null value. So -1 will be taken as null value. Okay. So for that, again, we will do the similar operation df of rm, which is our room feature, is equal to -1. And if I do this, it says false, 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 false. But once I try to index it using df, you will see we have some values where most of the values are -1, -1, -1, -1. Yes. And then we can directly do a shape of 0 because we need only observations. And it says 40. So we have 40 such values which we are not getting printed with just is and a sum. So make sure that you understand this particular question, else you may lose marks. Okay. So this is the case for the 6th question. Now for the 7th one, again similar thing, but for the age feature. So first of all, we will check the unique values of age. So I will do df of age dot unique. Let's see what we get. And you can see that there are many values, but there is a -2. And you can't have a -2 age. You can have only positive values, right? So again, we need to filter it out and just check out how many values are for these. And that will be our null values. Okay. So df of age, and the thing we want is -2. It should be -2. We got, and you can see all the observations which are there is -2 is present here. And then we will take the observations set, right? So that is 50. So you have 50 value. So if you have done directly, you might not get, you might get 0, but now it's 50. So that's the thing here. Now again, similar type of thing, but for the reverse side feature. So here they have capitalized it so that you can understand it very easily. Okay. So again, we will take unique values of riverside, then only we will process it. So df of riverside dot unique, and you can see there's no unknown and yes. So unknown it can't be, right? So either it can be no or yes. Unknown it is not there, so you need to filter out that. So we'll do df of riverside is equal to UKNON. Okay, so sometimes it may be that you may have written wrong. So for this, just copy paste whatever value is there. Then do this, you will see that all values are false. But now if I index it again using my df, you will get all the values where it is, right? So here we have riverside unknown. And again, if we do a shape of this, we will get the number of missing values, right? So it's 88. I hope that you understand this. It's very important that you understand this particular thing, else it will cause an issue, okay? Now for question number 9, how many houses are on Riverside were built within last 50 years? That is, house 50 years old or young. For this question, ignore the rows that have missing values in either Riverside feature or age feature. So for this, you need to filter this, right? So filtering is based on what? There are two criteria. First, Riverside should be yes, as we have seen previously from the unique values, and age should be greater than or equal to 0. Now, one might get caught with this year word, and they might try to find if there is year or not. So just go to your metadata and understand this. And here you can see that age of the property in years it says, right? So it can either be year or age, but here they have given age. So they will play with these type of things. So make sure that you understand this. So for this, I simply do a filter condition is equal to, and here it is very important. Don't directly do like how we were doing here, right? You need to chain it. And for chaining it, you have to use bitwise operators for this. And the best way is to use the small brackets and then write your conditions. So df of Riverside is equal to, yes. And this is the bitwise AND operator that I was talking about. Next condition, df of age will be less than equal to 50. And you might do this and try to get the same. And you will get like 4,000. And you will say, what? We have already the 4,000 values and we are again getting the 4,000 values. So just let's inspect it, right? All the age should be positive values greater than 0, right? So df of a is greater than equal to 0. And now, since we are having a Boolean result of filtering series, you can directly do this and you can see that all these conditions are met and we are getting this. And for checking the shape, you can do dot shape 0. And you can see that now we are getting the actual value, which is 40. But don't get caught up on these small details because it will cause you lose your marks or get yourself in trouble, okay? 10th. How many houses are near to exactly 6, 7, and 8 highways? So for this, you don't need to worry about this small detail that we did here, right? Because it says exactly 6, 7, 8 highways, right? And all three are inclusive. So we have to write separate functions so that these values gets included in that. So that means greater than equal to less than equal to. Again, we will do filter condition is equal to, I will be writing two conditions, df of, and paste it here. And we will say it should be greater than equal to 6. That means 6 is included. And df of highway count is less than equal to it. So all the things that are in between that we need, okay? So this will give us a Boolean mask. And now if we do simple filter, df of filter, and you can see that all the values which have highway count between 6 and 8, we are getting that. And now if we check the shape of that, we will get shape of 0 and it's 1, 2, 1 word. So that's your answer here. So till now we have done a very simple processing. But now let's move on to intermediate level processing. Now most of the time in your dataset you will have categories and you want to bin them. So for binning, this particular question will help you to understand how to do that. And here it says we have to create a column category and divide the houses in category as the following. So this is category 1, category 2, category 3, category 4, category 5 and all the conditions which are present. How will you do that? We will look into this. I will suggest you create a function and then use the applying method on the data frame. So I will first create the function. Okay. So for this, I will write create and any variable I can pass parameters. So I'm using a small x. And then if my x is less than 10 because it says 10 lakhs. So less than 10. I will return 1, that is category 1, okay? If my x is between these two values, right, 10 lakhs and 20 lakhs, 10 lakhs included and 20 lakhs excluded, then I will return second category. And also here it will be elif because if will execute directly. Even if this condition is true, then it will check for this. But elif will only execute if this condition is false. Okay? So that make sure that you understand this small nuances. Elif. Next category is 20 and 30. So again, we will be doing the same thing. 20 less than equal to x less than 30. And this we will say return 3. Then elif 30 less than equal to x less than 40. And then return 4. For the last, we don't need anything. Return. So we are done with everything that we need and we have our function ready. So for sanity check, just make sure that you check it once. For this, I am just passing a value between 20 to 30. Let's see what it returns. A is equal to, that means answer is equal to 25. And if I print A, which I can do directly without writing print, you will see that it comes under category 3 because 20 to 30 is 3. Okay. So that means we are good to go. And now we can use the apply method to check our values. So column creation is very simple. You have to do df of what was the name of the column that we wanted. It was category, right? We will do category is equal to df of price, because without price, how can you apply? So all things where under house price column was required. And then we need to do apply. Apply is a method which will help you to apply all the processing that you have done earlier using the function to your entire particular column or data set. So it just expects a function, but make sure that you don't call it. You just need to pass in the function name. So here I'm going to create and we are done. Now if I do a df print, you can see that we have a column called category which has been applied. Okay. So now once we have this, we can directly take the highest number of records which category has. So for this, we will do df of category dot value underscore counts, which will return all the values with their number of observation each value. Okay. Or you can do a mode also because it's a series. So we can do. So it says third. Next, move on to pre-processing part, which is basically processing our data for the model. And for this, first thing is we need to divide our data into train, test, split. Okay. And these all things you need to take care first of all. So we will first be doing this particular thing and then we will be taking our train, test, split and doing everything. And you can use the documentation to look at how train, test, split works. Okay, but I will be giving you some of the ideas. And first of all, let's do this replacement and everything. So replace a string or unknown value. Now this comes from the checks of whatever we have done from the unique. So you just need to check the unique values once. But since we already know what is that, so we will not be doing that. We can directly do this df of rm is equal to df of rm because our rm had this -1 value. So we needed to replace it. So replace is the method which we'll be using to replace our current value with some other values for this -1, np dot nap. And by the way, np stands for numpy. Okay. Now next we will be doing it for the viewer side, right? df of viewer side dot replace what was the value which was present in our viewer slice. It was unknown. So unknown, np dot name. Again, I will suggest create a function and then try this. Just pass in the values and np dot nan and convert it. But I am doing it the raw way. So df of age. That's why we did all these processing earlier to just check what are the unique values and everything. Right? So for this, we have df dot age dot replace, comma. We have minus, right? -2. We need to handle that -2 is to comma np dot nan. One thing to note here is that if you are not using this particular left hand side section, then you need to pass in a parameter called in place equal to true, else it will just return a copy. So make sure that you do the exact same thing if you are using the raw methods, else it will cause an issue. Also, don't mix up things. That means -1 is an integer. So make sure that it's passed as an integer only. It's not passed as a string. Okay. Now this is done. Let's run this. And if I do this and if I do is any dot sum, you can see that earlier it was not getting recognized, but now it's 40, 50 and 88. So whatever we got earlier. So that's good to go. After that, we need to do this step. So this is jumbled. You need to make sure that you understand how to do this. First of all, you will take your data and split into features and targets. So for features, I will be using x is equal to df all the values except minus, right? So I will simply do a df dot drop method and apply it on the price column so that I use my price. For the y value, I will simply do a df of index into price, because by default, whatever will be returned will be a copy and it will be stored in x. So I have this df intact. It doesn't change there, right? So for this, I can directly use this to access my price, right? So df.price, and we are done here also. Okay. Also, by the way, if you are wondering why we have price, it's because you have this column parameter. Now you have. So if I do a small print of text here, so you can see that everything is present except the price, right? This is the thing that you need to make sure to understand it. Okay. Now we will do a train test split. So for that, I'm just going to write few variables. So I will do test size is equal to 0.3 because it says in our question it's 30% will be test data, and random state is just for reproducibility. So I'm doing random val is equal to 0. And now we need to import our train test split. So for this, we will do from sklearn dot model underscore selection import train test split. Okay. And once you have done this, it's time to use our train test split. So the basic way is x train, x test, y train, y test is equal to train test split. Now you need to pass in values. So x comma y, which is our features and labels. Then we have our test size is equal to test underscore size, and then we have our random state is equal to random, right? So this is the thing that you need to do. And once you have this, we can directly solve our question, what is the number of samples in our training? So let's say if we have any error with this. So we don't have any error. Now let's check. We have 2,800 rows and 14 columns. Just do a shape of 0 to make sure that we are getting the same thing. Yes. And it's 2008. So 2,800 samples are there in our training data, which is basically the features. And we are ready to move on to our most technical assuming question, which is creating our processing pipeline. So guys, now it's time to create our processing pipeline. And in this particular thing, you have all the steps mentioned that you have to apply. And the way I'm going to do it is I'm using pipeline and column transformer to apply the same things. Because if you do it manually, it will take a lot of time and you may get into errors and everything. But pipeline simplifies the process. And you have to apply all this processing in the same order as it is mentioned here, because later on it may cause issue for your next questions or any further processing. And you can use multiple instances of transformers, which are basically nothing but objects to apply transformation. First of all, we need to import a lot of libraries. So let's import them. Imports, and the imports include pipeline. First of all, from sklearn.pipeline import pipeline. Okay. After that, we need to import the column transformer from compose. So from sklearn.compose import column transformer. By the way, if you don't know about pipeline and column transformer, you can always refer to my video, which I have pinned above. So after this, we need to import our processing objects. So for this, we will do from sklearn.processing import min-max scalar, standard scalar, and one for encoder. After that, we will just do a simple imputation. So for that, we need to import imputer. So sklearn.impute import simple imputer, right? Let's check if everything is getting installed right now. So you have to just write the right name. So actually it's preprocess. Okay. By the way, if you are wondering how I know all these methods and everything where it resides, I don't know. I just use the API principal guideline to understand which will be available where. Obviously, they may trick sometimes, and you can refer to my pinned video to learn about those API guidelines and how you can utilize it for your benefit. Okay. Now let's do our first step, which is to trap the category column, and it's pretty important here. Okay. So for this, I will do X train because we have our training data now. We don't have our normal data, right? So training data, that is X train dot drop. What we have to drop based on column its category, right? Now here comes the interesting part. If you directly do it, you will get an copy and it will not be reflected in original data, right? So for that, you need to fix it. For that, we will do in place equal. And once you do this, it will get reflected in explain itself. If I do now explain, you can see that I don't have category column. That means we are good to go here. And now here are all the things that we need to do. These are all the steps that we need to provide, but we will be since using the pipeline. So I will show you a very interesting way to do this. It's like you have to create multiple processing pipelines and combine them together. So first of all, we will use simple pipelines, right? Use simple processing. So for this, we have our min-max scaling, standard scaling, and that's very common. Most of the columns have this. First of all, we need a min-max scaler, and I will instantiate my object with min-max scaler, which I have imported here, min-max scaler. Then I will do simple imputer. So simple imputer is equal to, again, I will be copying it from here only, save my time, simple imputer, right? So these two are simple processing pipelines. Now let's move on to more complex, where we need to include multiple. So for this, I will be using my pipeline to create it. So first of all is median and min-max scaling. So for this, I will do median, impute, min-max. I'm just keeping it for the reference, these names. You can do whatever you want. So pipeline, first of all, we need to import so that we can create our pipeline for pipeline. And then the way we pass the pipeline is we have to pass it in the name tuple to this, and then we need to pass the tuple. First object in this particular thing is the name of the pipeline itself. For this, we will median imputer, comma. Now we can directly use this simple imputer object or this one also if you are not sure, and pass in this strategy, which is again a parameter of this simple imputer, as median. Now once you have done this, you have your first name tuple. Now we need to do a min-max scaling also. So for next, we will do min-max scale the min-max scale, or you can directly use this also. This, and this is your first median in your min-max pipeline. Similarly, I will be creating more of these, say 3. First one is this, second one is this, third one is this. Now I'm going to change it here. Here it will be mean. And again, our imputing strategy will be mean and then min-max scaling. So here our strategy will just change, nothing else. So mean and min-max scaler is same thing that we have defined earlier, also no issue with that. And after that, we have this most frequent value with one hot answer, right? So here we need to change a few things. First of all, the variable name itself, most frequent one hot, and here since it is most frequent, strategy will be our frequent thing else. So most frequent, and this one will be nothing but our one hot encoder. Since we haven't defined one hot encoder earlier, we can directly do this here only. One hot encoder is done, and now we need to create an object. This, and now we are ready to go. Okay. Now, in case you don't know what all the strategies are available and everything, just do this, and then after importing, you can see that you have this doc string. Now, if you look at this parameter of strategy, you can see this. It is mean, median, most frequent, constant, and everything. So you can actually check from here and implement. Once you have done this, now we will be applying all these transformations that we have seen here to our column names, CRIN, ZIN, index, polyindex. And make sure that you don't do errors here, because same processing might tempt you saying that we will use all these columns. No, you don't have to, because here if you see, index has just standard scaling, right? It doesn't have this min-max scaling. So first of all, you have to separately do this, then move on to other things, right? So now let's use the column transformer to do all these stuff. So I will just create a processing pipeline is equal to column transformer. And again, it also works on the similar method, just that here you can pass 3 values. First one is name of whatever function you want. Second one is the function itself, which we'll use to process it. And third one is the name of the columns that you want to apply it, okay? And it again takes a name tuple array. So we will do min-max scaling. And since we are using 2 or 3 scalars, so we will be using 1 just to distinguish them, nothing else. And then we need to pass simple min-max scalar, because most of the columns require simple min-max scalar itself. And then we need to pass in the column names, and it will be passed as an array or list. So you will do CRIM, Z. So first processing will be done on these 2 only. Don't do it on all the columns. This is what I have learned hard way, by the way. Okay. After that, you need to do a scaling operation. So for that, I will do standard Scaling, by the way, if you're thinking why I'm giving meaningful names, because later on you can access those using the meaningful name. If you not do that, it will have an issue. So that's why I'm doing this. So standard scaling, and standard scaling means we have to use standard scaler. So standard scaler is here. Obviously, we haven't defined it because it was not used a lot. That's why I'm doing this directly here. Okay. Then I again need to pass even if it is a single column into a list. So standard scaling is in this, right? Once we have this, now we are good to do with our min-max scaling too, which includes a lot of columns that we can use. Okay. And here we will change the column names. Okay. Here it's a good practice to copy it so that you can work directly with it. Here I'm going to copy each and every one and going to paste it inside here. Poly index, comma, dish, comma, highway count, comma, tax, then comma, PT ratio, comma, IMN, comma, BPL, and then close the itself. And now we have this entire thing. Next, we need two complex imputations. So for that, I'm again going to create a new name tuple called median imputation. Right, so we had this. Here I will pass the name. I will also pass the function itself or the pipeline itself and the column name on which it needs to be applied. So column name is RM if I wrong. So RS. Next, we will do a similar thing, but with mean, right? Again, I copy it, paste it, and then paste it. And now I'm going to change it. Next is mean impute min-max. Mean impute to min-max in third. Where on which column we want to apply it? It is on age, right? So age. Now finally is most frequent one hot. So most frequent one hot, and then most frequent one hot, and then revert it or reverse it, right? So this is the entire pipeline, guys, that we need to create first of all before any processing or anything, and make sure that you understand, right? Let me check if we can run it. Yes, we can run it. There are no errors. Now if I do print, you can see that everything is visible, whatever we are doing here, right? And you can have your documentation from here or itself. And if you expand any one of them, you will get everything in detail, whatever you are doing, right? This is the power of pipeline that we can do. Now, next, we need to solve the asked question, which is how many features are there after performing a transformation. So let's perform the transformation itself. And for that, I am going to use fit_transform on extrain it. Okay, so I will do processing pipeline, which will be our entire pipeline that we have defined here. Dot fit_transform because it's a transformer object. So we can do transform. And then let's see what we get. If I processed, you can see that everything is processed clearly and it is now an array because all the methods that we have applied here, but in shape and it is still is there and it's 2800 comma, right? So this is the thing. Now if you think that I am somewhere wrong, you can always point me out in comments, so make sure that you do that. And after that, once this is done, let's move on to our last question, which is basically mean of transform test data, which is features all. And it should be computed on the whole feature matrix, and mean of all the values in transform test feature matrix. And here you will see the power of pipeline. Once we have defined our pipeline in this way, you can use this particular pipeline and again apply the transform method directly to your X-test. And it is because our test data features, right? At test, and now I will do test data processed is equal to processing pipeline transform text. This is test data processed, and now if we want to see it, it is the entire thing. And now if I take a mean of this processed data, it will be 0.386, right? So these are all the things that you can do, and these are the set of questions. Obviously, you can do a lot more with pipelines and everything, and I highly suggest that you go with all. So guys, that's it for this particular video. I hope that you understood this, and make sure that you please practice all these things, especially all the tips and tricks that I have shared along while solving some of the questions. And make sure that you understand that processing pipeline, which I defined earlier. Always suggest you to refer to your documentation, and all these things will be available to you in my GitHub repo. Also, if you are finding this useful, make sure that you share it with others so that they can also get benefit with it. And if you have some doubt, please ask me in comments. See ya in next video. Till then, bye-bye.